Hey everyone, just want to welcome you to week 5, module 5 for ME 270 structural dynamics. This week we'll begin the study of force motion by looking at the response of undamped and viscous damped single degree of freedom systems to a harmonic, in particular sinusoidal, excitation. So this overview video will be added to your lecture materials under the overview section of module 5. So you can take a look right to the right of your overview section there, and every week I'll be doing an overview video of the lecture so you know what to expect for material that's going to be covered in the lecture slides, as well as what's going on with homeworks, quizzes, exams, and all of that stuff to keep you up to date with your course schedule. So homework number 2, a reminder now, is going to be due on the 28th, Monday the 28th by 11 p.m. Please reference back to your homework guidelines for any details on formatting, grading, and submission. You should have received your grades already for homework number 1, so you understand what I'm looking for formatting and everything there. If you have any questions beyond what's in the guidelines and your feedback on the homeworks, please feel free to contact me via email or on Teams. Reminder, I do have office hours scheduled for Tuesdays and Wednesday mornings. If those don't work for you, send me a message or an email and we can set up a time to meet on Teams. Quiz 5 has also been posted, so Quiz 5s will be due on October 2nd by 4 p.m. And the big ticket item here is Exam 1. So your first exam is going to be assigned on Wednesday, September 30th at 8 a.m. and it's going to be due that same day, Wednesday, September 30th by 4 p.m. So that gives you just between 8 a.m. and 4 p.m. on Wednesday to complete that, submit it through Blackboard and get it scanned in and everything set. You should be familiar. Everybody's turned in 2 homeworks, or first homework, you'll have the second homework today turned in, so you understand how to do it through Blackboard. It's going to be the same type of formatting for this exam as it is for your homework, same method of submission. Difference now is you just have that one day to complete it. It's going to be 2 problems covering all the material we've gone through up to this point, and you'll need to submit it the same exact way through Blackboard you had before, so scan it as a PDF and upload it through there. So this is designed as 2 problems that you can complete as an in-class in normal times if we were sit in person exam. But I'm giving you the whole day, not just the hour and 15 minutes to do it. You're going to have between 8 a.m. to 4 p.m. in order to complete this exam and get it submitted through Blackboard. So for Module 5, we're going to be looking at Chapter 5 in our textbook, with the response of single degree of freedom systems to non-periodic excitation. Now within this module, we want to be able to apply the classical differential equations method to determine the response of a single degree of freedom system to impulse loading at time equals 0, step loading at time equals 0, or ramp loading. We're also going to want to be able to describe the difference in the response system loaded rapidly as contrasted to the response of the same system when loaded slowly. So what's the difference between quickly loading it and slowly loading it? We also want to explain why the maximum dynamic response to a pulse may occur after excitation has ceased to act on a system. We're going to want to use the convolutional integral to determine the response of a single degree of freedom system to simple loading histories. And last, we're going to take a look at Laplace transform again. You can reuse the Laplace transform to determine the response of a single degree of freedom system to simple loading histories. So this is going to be broken down into 2 different sections. First section is going to be Module 5.1. In this section here, we're going to take a look at the response of single degree of freedom systems to this non-periodic excitation. In particular, we're going to look at the response of a viscous damped single degree of freedom system to an ideal step input. And then we're going to look at the response of an undamped single degree of freedom system to a rectangular pulse and ramp loadings. So one of the problems we're going to be looking at throughout this section here is these spring mass damper systems. So what we can see here is on the right we have this diagram here. Here you have your mass moving on a surface here. You have your spring constant K, your damper over here C, external loading P of T here, and displacement U there. So from this we're going to have an idealized step function input. So you can see over here a realistic step input versus an ideal step input, where a realistic one follows this dotted line here, comes up around like this here, where an idealized one is perfectly square. We come up, boom, right up 90 over like this here for an ideal step function. So the next section here, we're going to have Module 5.2. In this section here, we're going to look at the response of undamped single degree of freedom system to a short duration impulse or a unit impulse response. So if we look at impulse response here, this is a very brief high magnitude input. So the area, if we go over here to our graph, we have P of t on our y-axis and we have time on our x-axis here. The area of this impulse is not negligible, and we can be calculated by using our P naught, delta t right there. So we can see our delta t right there and our P naught right there. So base times height of a rectangle is going to give us our area there. Now we can assume that delta t is small relative to the time scale of the output so that it can be considered instantaneous.